Hello everyone, welcome to Neso Academy. Till now we have understood some important terminologies of machine learning under the topics dataset fundamentals, data splitting, and performance concepts. Now in this lecture, that is machine learning pipeline, we are going to understand the complete journey of a machine learning model from problem to prediction. Machine learning pipeline is also known by its alternative names like designing a machine learning system or steps to build a machine learning model. So the topic for this lecture is machine learning pipeline. Let's get started. Machine learning pipeline is a step-by-step process followed to build a machine learning model. What does that mean? It means to build a machine learning model, we need to follow a step-by-step process. And that step-by-step process is known as machine learning pipeline. For example, when we cook food, we follow some steps. When we solve a mathematical problem, we follow some steps. Similarly, in machine learning also, we follow a proper sequence of steps to build a machine learning model. We don't directly give data to the machine learning model. First, we need to understand the problem statement. Then we need to collect the data relevant to that problem. Then we have to clean and prepare that data. After that, we train our machine learning model. Then we test our machine learning model. And then we can use the machine learning model to make predictions. That means we cannot use machine learning model directly for making predictions. First, we need to follow some steps, and after completion of all the steps, then we can expect our machine learning model to make predictions about the data. And in this lecture, we are going to understand the flow of complete machine learning pipeline. From the upcoming lectures, we will understand each of the steps of this ML pipeline in much more details. So the very first step in machine learning pipeline is problem definition. Yes, problem definition is the very first step in building a machine learning model. That means, before building a machine learning model, we must clearly understand the problem statement that we are trying to solve. This is a very important step because if problem is not clear, then the whole machine learning process will go in wrong direction. For example, in house price prediction, what is the problem statement? Obviously, the problem statement is to predict the prices of the houses on the basis of features of the houses, like house size, number of bedrooms, age of the house, location of the house, and so on. So in the first step, we define problem statement and we also identify the three components of a well-defined learning problem that are performance measure, experience, and task. So, after defining the problem statement, the second step is data collection. Obviously, after defining the problem statement, we need to collect data for the machine learning model because machine learning model learns patterns, features, and relationships from the data. That is why we collect data from different sources. What can be the different sources? Like companies' databases, surveys, sensors, and so on. Now, in this particular step, that is data collection, the quality of data influences directly the performance of the machine learning model. That means if the quality of data is very good, that means the performance of the machine learning model is also very good. But if the quality of data is bad, then the performance of machine learning model will also be very poor. So, the data that we need to collect should be relevant to the problem statement. Machine learning model cannot learn from less or incomplete data. So I hope second step is now clear to you. After data collection, tell me, should we give this data directly to our machine learning model? No, not at all. First, we need to remove some problems from this data because the raw data that we collect is very messy, unstructured, unformatted, and inconsistent. That is why we need to perform basic data cleaning. So the third step of machine learning pipeline is basic data cleaning. What do you mean by basic data cleaning? It means to remove some obvious problems or errors from the data that we have collected. Now, what can be the problems in this data set? There can be some duplicate rows, there can be some irrelevant columns, there can be some missing values. So all such problems are handled in this particular step, that is basic data cleaning. For example, in case of house price data set, there is a column called as house size. Now, if that column contains some negative values, then it is an error because size of the house can never be negative. Also, there can be some missing values in that data set. There can be some spelling mistakes. There can be some unformatted text. All these problems are removed in basic data cleaning. Now, after basic data cleaning, the fourth step is data splitting. In the previous lectures, I have already explained you very well the meaning of data splitting. Data splitting, or we can say train test split, is the process of dividing the total available data into two parts. The first part is the training data. The second part is the testing data. Training data is used by the machine learning model to learn patterns and features. And testing data is used to evaluate the performance of the machine learning model because it is an unseen data. Now, the training data is usually larger than the testing data. Why? Because training data is used by the machine learning model to learn patterns and features. That is why it is required by machine learning model in larger amounts. But testing data is used to evaluate the performance of the machine learning model. That is why it can be less. So, the standard data splitting ratio is 80:20. That means 80% of the total available data is training data and 20% of the total available data is used as testing data. Now, there is one important point that you should note. Before performing the data splitting, that is, before dividing the data into training data and testing data, we must first separate the features and labels. For example, in case of house price dataset, we must separate the house details from the house price. So, the house details like size of the house, age of the house, number of bedrooms of the house, location of the house must be separated from the actual price of the house. Only after that we can perform data splitting, that is, dividing the data into training data and testing data. So I hope data splitting is now clear to you. After that, the fifth step is data pre-processing and feature engineering. So after data splitting, we need to prepare the data. Now, data preparation includes data pre-processing and feature engineering. Let's first talk about what is data pre-processing. Data pre-processing is the process of converting the data into a format that machine learning algorithm can understand. So, in data pre-processing, we convert our data into a format that is understandable by machine learning algorithm. For example, a machine learning algorithm understands numeric data better than textual data. Now, suppose there is a column in a data set known as location, which contains the values like Chennai, Mumbai, Agra, and so on. Now, these textual values needs to be converted into numerical values so that our machine learning algorithm can understand them. This is one of the examples of data pre-processing. But data pre-processing is a very vast field. It includes categorical encoding, handling missing values, handling outliers, feature scaling, data transformation, and so on. Don't worry, I will explain you each of these terms when we will understand data pre-processing in details. Now, the second one is feature engineering. What is feature engineering? It is the process of creating new features from the existing features. For example, there is a data set which contains a column known as date of birth. Now, if we create a new column called as age from date of birth, then this is known as feature engineering. Obviously, age can be easily derived from date of birth. So we have created a new feature, that is age, from the existing feature, that is date of birth. So this is feature engineering. And why feature engineering is important? Because it makes the data more meaningful for the machine learning algorithm. So now I hope you have a basic understanding about data pre-processing and feature engineering. After that, the sixth step is selecting algorithm. That means we need to select an appropriate machine learning algorithm for the machine learning model. So what is a machine learning algorithm? Machine learning algorithm is the method or approach used by machine learning model to learn patterns from the data. I have explained you that machine learning model learns patterns and features from the data. So the approach or method used by the machine learning model to learn patterns from the data, that approach or method is known as machine learning algorithm. Now the choice of machine learning algorithm depends on the type of problem. For example, in case of house price prediction, we need to predict the prices of the houses. And price is a numerical value. That is why we choose a regression algorithm, like linear regression. If we choose a wrong machine learning algorithm, the machine learning model will give poor results, even if the quality of data is very nice. So this was the step number 6, that is selecting a machine learning algorithm. So till now we have defined the problem statement, we have collected the data, we have applied basic data cleaning. After that, we have splitted the data into two parts, training and testing. After that, we have prepared the data, that is data pre-processing and feature engineering. And after that, we have selected an appropriate machine learning algorithm. Now it's time to train the machine learning model. So the seventh step is model training. In this step, the machine learning model learns the patterns and features from the data. Machine learning model learns the relationships between the feature and target variable. For example, in a house price prediction system, the linear regression model will try to identify the relationships between the house features and the house price. For example, if the size of the house is bigger, the price would be higher. If the location of the house is better, the price would be higher. Like this. So this is known as model training. Now after model training, the eighth step is model evaluation and pipeline saving. So what is model evaluation? Model evaluation means model testing. That means after training the machine learning model, we test the performance of the machine learning model on unseen data. In this way, we evaluate our machine learning model, how well it is trained on the training dataset. So, model training is done on the training dataset, and model evaluation, or we can say model testing, is done on the testing dataset, which is unseen for the machine learning model. Now, after model evaluation, there is pipeline saving. What is the meaning of pipeline saving? Now, after the model is evaluated, if it has a good performance, then we need to save the machine learning model. Why to save the machine learning model? So that we don't need to retrain the machine learning model again and again from the beginning. This is known as saving the machine learning model, or I can also say saving the entire pipeline of machine learning. Now, after model evaluation and pipeline saving, the ninth step is making predictions. That means the trained, tested, and saved model is now used to make predictions on new data. And this is the actual practical use case of machine learning. All this we are doing just to ensure that we will make predictions on the new data. Suppose a user enters the details like size of the house, location of the house, age of the house, number of bedrooms of the house, and so on. And model predicts the price of the house. This is known as making predictions on new data. And this is the actual use case of machine learning. Now, after making predictions, the last step is monitor and iterate. What is the meaning of monitor and iterate? it is to be noted that this machine learning pipeline does not end after making predictions. After making predictions, we need to keep on checking the performance of the machine learning model over the regular intervals of time, so that we can check whether the machine learning model is still performing good or not. This is known as monitoring of a machine learning model. And what is the meaning of iterate? Iterate means to continuously improve the performance of the machine learning model. For example, the house prices may change after few months. That is why we need to collect the new data. Then we need to retrain the machine learning model. This process is known as iteration. So, monitor and iterate means keep on checking the performance of the machine learning model and improving it wherever required. So, this is the entire machine learning pipeline that we have discussed. First, we define the problem statement, then we collect the data, then we clean the data. After that, we split the data into training and testing data. After that, we prepare the data, that is data pre-processing and feature engineering. After that, we select an appropriate machine learning algorithm. After that, we train the machine learning model. Then we test and save the machine learning model. After that, we use the machine learning model to make predictions on new data. And we continuously monitor and iterate the performance of the machine learning model. In this way, we are done with our topic, machine learning pipeline. In the upcoming lectures, we will understand each of the steps of this ML pipeline in more details. So this was all from my side for this lecture. Thank you, and I'll see you in the next lecture.